All right, guys, so now that we have talked about speed and velocity, and we have talked about acceleration and velocity, we need to talk about how to represent those things graphically. So today we're going to talk about position time graphs. So position time graphs are graphs that represent where you are at a certain position at a certain time. And in order to find your position or find where something is, you just have to read the graph. The catch is when you read the graph, you need to watch for the units. Watch the units, watch the direction for this position thing. All right, so a position time graph provides two things. It can provide us with one, something's position. I mean, that's what it says in the title, right? And number two, it can provide us with something's velocity. So we're going to start off pretty basic with these, and we're going to get a little bit more advanced. So we're going to start with what the obvious, most easiest thing to do is. And it says, what is the position of the object at 5 seconds? So you will find 5 seconds. And you'll look where the position is. And it's at 0 meters east. Then we're going to find where it is at 10 seconds. So we're going to go to 10. We're going to find where it intercepts. And at 10 seconds, it's at 20 meters east. When the time is 20 seconds, we're going to go all the way up to the top of that position time graph. And it looks like our location is 100 meters east of our reference point. Last but not least, at 25 seconds, we're going to find that position. And it looks to be roughly 90 meters east. So to find the position of an object, all you have to do is read the Y. And this is your Y right here. So that's what you're looking at. You're reading the Y axis, and that's going to give you that position of the object at different intervals of time. Now we want to know about velocity. So that's when we're going to take another look at this. Position is the most obvious thing to get off a position time graph, but we can also get velocity. So velocity is represented on a position time graph by the slope of the position time graph. So if you remember from math, slope is equal to rise over run. So the slope is equal to the change in distance over the change in time. So I can represent that mathematically as the slope, m, is equal to the change in distance over the change in time. All right. Yeah, Matthew, can you go look this up in Mr. Payne's classroom for the day? Where I haven't changed anything about my lifestyle. It's just the room has changed. You're welcome. All right. So, slope is the velocity. So the greater the slope, the greater the velocity. So before we add the actual math to that, let's look at some of this up here. Some things we need to know is that when the slope is positive, whatever we're graphing is going to be moving in the positive direction. And when the slope is negative, it's moving in the negative direction. All right, so let's look at this before we add numbers, and let's just talk about what's going on in this position time graph that we're looking at. So from 0 to 5 seconds, there is no slope. The slope is 0. There's a horizontal line. So from 0 to 5 seconds, it stopped. Nothing is going on from 0 to 5 seconds. Where we start to see this curve is when acceleration happens. So this curve represents acceleration. Now we're going in a straight line. I use yellow on my sheet, but obviously a yellow marker isn't going to show up, so I'm going to use blue. We're going in a straight line up here. So we're moving at a constant velocity. We have on cruise control. However, we need to know what direction we're moving in. We're moving positively. Our slope is positive, and that position is going to be east. All right, when you start to see this curve again, that means our slope is changing. We're getting a change in the slope, so that means we are decelerating. For a period here, we stop because our slope is 0. And then we're moving at a constant velocity again. We have another straight line right here. So this is another constant velocity point on the graph. However, our slope isn't going to be positive here. Our slope is going to be negative. And when we look at this graph, this represents position east. So if east is positive on this graph, then negative would be west. So because this velocity over here is negative, we're going to say we're moving in a westward direction. All right, so let's look at the math that actually goes with this. If we want to know the average velocity of something between 0 and 5 seconds, we need to set up our math first. So we have our velocity is equal to our rise over our run. So our velocity is equal to, at 5 seconds, we were at 0. So at 5 seconds, we were at 0 meters and 5 seconds. So that's our final position and our final time. At 0 seconds, we were at 0 meters and 0 seconds. When you do the math, you get your velocity is equal to 0 meters per second. So what does that mean? That means that you're stationary. If you were the tortoise and the hare, you are the hare and you are taking a break. You haven't started the race yet. You're going to let that turtle get a head start because he is so slow. Now we need to know what's going on between 10 seconds and 14 seconds. So our slope is equal to our rise over our run. All right, our final time we were looking for was 14 seconds. So I'm going to put that on the bottom. Our position at 14 seconds looks to be approximately 85 meters. Then we're going to put our initial time on the bottom. Our initial time right here was 10 seconds. And at 10 seconds, we were at 20 meters. When you do the math, you get approximately 16 meters per second. Because this isn't in a calculator or a computer, we don't know the exact value of 14 seconds. We don't know the exact value at 15 seconds either. It's an estimate. So because of that, our answer is an estimate. And it's positive. So we know that between 10 and 14 seconds, the velocity was approximately 16 meters per second. It's a vector, so we need directions east. All right, the last problem we have is we want to know what that little rabbit was doing between 20 and 25 seconds. So we're going to say slope is rise over run. Our final time was 25 seconds. And at 25 seconds, we were at 90 meters. So that's where that rabbit was at 25 seconds. At 20 seconds, our initial time, he was at 100 meters. When you put all of this math and figure it out, you're going to get -2 meters per second as his velocity. That negative doesn't mean he's traveling backwards. It means he's traveling in the opposite direction of the graph. So if the graph is representing positive as east, we have a negative value. So this little bunny is going to be traveling west. So because it's negative, between 20 and 25 seconds, he is traveling 2 meters per second west.